All right, guys, we are on day 13, and let's look at our do now problems. So our directions say that we are going to be sketching a graph of the equations, and then we want to label the following items. So as a refresher from yesterday, and I'm going to write this on a sticky note just because it's not necessarily part of today's notes. Just want to remind everyone that whenever we look at an equation in slope-intercept form, remember that this is the layout. Y equals mx plus b. And in this equation, m, or the number that's attached to x, is our slope. And b, or the number that comes after the plus or the minus sign, is our y-intercept. All right. Now, real quick before we go through these, what's another way to write slope? Who remembers? Rise over run. And if you weren't here for that yesterday, hopefully it'll make a little more sense whenever we get to the application of that. So, let's look at our first equation. We have y equals negative 3/4 x minus 2. So first of all, what is our slope? Negative 3/4. Perfect. So in this spot, you could just write negative 3/4. All right. Now, without doing any math, without solving for anything, can we already tell what our y-intercept is? Negative 2. That number at the end is negative 2. So our y-intercept is negative 2. Now, we can solve for our x-intercept, but before we do that, let's look at how we would graph this. So, I'm going to move my paper up a little, and I'm going to draw a little bitty graph. First, we're going to draw a y-axis, then we want to draw an x-axis. And my graph is not perfect, guys. Bear with me. We're going to draw a couple little tick marks here. Man, I'm scared I'm not going to have enough room for this. I might have to double up my tick marks like this. Alright, I'm going to double them up. Okay, so first thing I like to do is label my axis, my x-axis and my y-axis. So I'm going to do that by writing an x next to the x-axis and a y beside the y-axis. All right. Once we've found our slope and our y-intercept, without doing any sort of math problems here, we can already graph this line. Can anybody remember what we should start with to graph this line?
0.
Start with 0. Okay, yeah, so let's look at that y-intercept. Thank you. The x is 0, and the y is negative 2. So where would we put this on?
0 in center of the x.
Uh-huh. So we're going to go over 0 on the x-axis, and then our y is negative 2, so how many up or down do we go? Down 2, thank you. So we go 1, 2, and we're going to plot this point right here. This is our y-intercept. So I'm going to label it 0, negative 2. Okay. So remember, guys, whenever we are plotting our y-intercept, all that tells us is where our line is going to be touching the y-axis. That's all it tells us. So now that we have our y-intercept, we can use the slope to give us another point. Now, I drew my graph a little bit poorly. I didn't plan well for this. But what would I do to find out where my next point is? Can somebody explain that to me? Yeah, we're going to be using that slope, -3/4. And remember, we said earlier that slope is equal to rise over run. So that means our rise, or how far up or down we go on the y-axis, is going to be -3. And our run, or how far over we go on the x-axis, is going to be 4, because we have -3/4. So here's what we would do from here. We have our y-intercept here, our first point, bless you, and we're going to start with our rise. Because it's a negative number, do we go up or down? Down. So I would count down 1, 2, 3, and then I look at my run, which is 4. So then from here I go over 1, 2, 3, 4. And this would be where my next point would be.
So, wait a minute. Do you start the down 3 from the point that's already on the...
Yes. So first step is you graph your y-intercept. Once you've done that, then from that point, you're going to do whatever your slope tells you to do. And in this case, it says to go down 3 and go over 4. So now we would just want to count on our axis, our y and our x-axis, to see what this point would be. So whenever we write a coordinate, it's x and then y. So I'm going to count here. I have 1, 2, 3, 4 for my x. And then my y, I'm going to start at 0 and count down to my point. I have 1, 2, 3, 4, 5. So it's -5 since we went below 0. Okay, so we found our 2 points. All we need to do from here is, so it's +4 because we're going the positive direction on the x-axis. If it was over on this side, it would be a -x. But the y is negative because we're below here.
How did we end up with the -5 on this side?
Sure. So for -5, all I did was I started at 0 on my y-axis, and I tried to see where that point lined up. So I'll show you with this ruler so you can see. I went down 1, 2, 3, 4, and then 5. And that's where this point lines up on the y-axis. Star, yes.
Ella's here. I've got to give her a ride. Oh. You want her to sit out and not come up there or come in here?
I don't mind. She can come in. Okay. So let's go ahead and connect these dots.
So x-intercept is 4, yeah?
Well, let's see. Let's see. Our x-intercept is going to be wherever our line touches the x-axis.
Okay.
So once we draw our line, we can get kind of an idea.
I think so.
So let's see here. Our y-intercept was 0, -2.
Right.
So it was down here. Our x-intercept,
-3.
yeah, it's probably going to be about -3. You're probably exactly right.
Okay.
So we can look at it visually and see this is where our line touches the x-axis, and you could count 1, 2, 3. It's probably about -3. But just to be sure, we're going to work the math out and kind of solve for that x-intercept. And I'm going to show you that process. So if we wanted to find our x-intercept, we can see that we have a coordinate here. We're solving for x, and we have y equals 0. So I'm going to use my original equation, which was y equals -3/4x minus 2. And I'm going to plug in a 0 for y. So that'll be 0 equals -3/4x minus 2. Now it's going to be just like when we were solving equations in the last unit. We're just going to use our inverse operations and solve for x. So what would my first step be here?
Plus 2.
Yeah, plus 2. So we need to do that to both sides. Those cancel. Now we have 2 equals negative 3 over 4 x.
We're gonna divide -3/4.
Yes. So let me show you how to do that on your calculator so that we don't get lost. So we have a negative 3/4 times x. To get rid of that, we would divide by negative 3/4. And we do that to both sides. And here's how I'm going to type that in. So first, I know we're going to be doing 2 divided by negative 3 over 4. So I would type in 2 divided by, and then I would put it in parentheses, just like I did here. I'd put parenthesis, negative 3 divided by 4, because that's the same thing as 3/4. Close the parentheses. So does everybody see what I did here so far? Divided by is at the right hand side, right under the clear button. Yeah, right there.
So is that, won't that divide this by 4, or is that just giving you the number?
So what it's doing is I'm taking 2 divided by negative 3/4. So it takes that negative 3/4 as the whole number that we are dividing 2 into. Does that make sense? No? Okay. Well, let me... That's all right. That's all right. So just instead of typing in like a regular number, like if this was a negative 3, we're typing in the whole fraction here. So then I'd hit enter, and I get negative 2.6 repeating. So that means,
So wouldn't it be 2.7?
yeah, we could say 2.7 also. Either one would be fine with me. That means our x is negative 2.7. So what we can do is look at the graph that we made and make sure that that point makes sense. Looks like our line touches the x-axis right about negative 3. Negative 2.7 is pretty close to negative 3, so it looks like we did it right. So for my x-intercept, I would write in my answer, which would be negative 2.7. Or negative 2.6 repeating, however you prefer to put it. Okay. Do we have any questions on that? Okay. Do we want to move on to the next one?
Yeah.
Okay, let's do it. So, same thing here. We have an equation, y equals negative 6x plus 12. And we're going to start by identifying the slope and the y-intercept. So, first of all, without having to do any math, what is our slope? Negative 6. So I'm going to write negative 6 right there. How about my y-intercept? 12, because it's plus 12 at the end. So we're just going to write 0, 12. Now, in the future, whenever you need to write out the x-intercept and the y-intercept as a coordinate, like I did here, just remember that a coordinate is always written in the same order. First there's x, and then there's y. So just remember, for your y-intercept, the number you find is going to go in the y spot. For your x-intercept, the number you find is going to go in the x spot. And the other numbers will be 0. Okay, guys, let's draw a graph. So I'm going to make my x and y axes. And maybe I'll do it up a Man, I gave you guys some large numbers. That's goofy on my part. One, 2, 3, 4, 5, 6, 7. Oh my goodness, this isn't even gonna fit on here. Okay, I'm gonna do it on a board separately so that you can see the actual whole thing. Okay, let me get a marker. So, we have here, let me make this so that you can see it. We found that our slope was -6 and our y-intercept was the coordinate 0, 12. What is our first step to graphing this?
Get your -6 on there.
So we are going to use that -6 for slope, but let's look back at the first problem.
We're gonna use 12.
What is the first point that we plotted before we did slope?
Y-intercept.
Yeah, the y-intercept. So our y-intercept is always going to be sort of our starting point. So we already have the coordinate 0, 12. So to plot that, we're going to go over 0, up 12. So I'll count 1, 2, 3, 4, 5, 6, 7. Okay, I'm not going to have enough. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, here's my first point. Okay, and I'm going to label that 0, 12. And that's my y-intercept. Yes?
Couldn't you just, instead of counting by ones, count by twos? And because 6 and 12 are both within the time of multiplying.
You are correct. I could have saved some time by counting by twos. So maybe I shall do that in the future. All right. We've got our y-intercept graphed. We've got that point plotted. Now what is our next step? What's our next step, guys? Yeah, we're going to use the slope. We're going to use that formula, rise over run. So our slope is -6. How could we write that as a fraction? Yeah, it would just be -6 over 1. Any whole number written as a fraction is just that number over 1. So our rise is -6. Our run is 1. So I'm going to start from my y-intercept here. And I'm going to do my rise first. It's -6, so do I go up 6 or down 6?
Down.
Down. So we'll count 2, 4, 6. All right? From the y-intercept, yes. Always from the y-intercept. Then my run is 1. So what am I going to do to show that? Go over to the right 1, which for me is going to be right about here. Now guys, what's really nice about slope, if you know the slope of a line, it just tells you how steep that line is. The steepness will never change. So once you have more points, you can keep counting down 6 over 1, down 6 over 1. I could get 1,000,000 points. So here's another 6, here's another 1. Here's another 6, another 1. Another 6, another 1. And we're going to end up with a super long line if I did it correctly. I did it wrong. There. Now it's right. Okay. And then all you would do from there is connect the dots with your ruler.
So is it kind of like finding a pitch?
Kind of like finding what?
Pitch on the road, kind of?
A
The
pitch.
pitch on the road.
I don't know what that is, but probably.
It's similar.
I bet you it's super similar to that. Okay, so here's our line. Now don't forget to draw arrows on the ends of your line to show that it does go on forever and ever. And then we do need to label our x-intercept. So guys, this will be an easy one because we know that it's always going to be going down 6 over 1, down 6 over 1, and our line is going to touch the x-axis right here on a nice even number. So instead of doing the math, we could just look at this and see that our point here is, it's my goodness, I'm having a brain fart. It's x is 2, y is 0. So
if I just put the 2 points on it and didn't do the down 6 over 1 more, I didn't get the same answer I got to have.
how'd you get 2.5?
Well, that's just what my line draws. I don't know because I didn't use graph paper. Or
Okay, it probably just wasn't perfectly straight, and that's okay. That's why I will say, as much as, you know, this is a pre-made graph, so my points are going to be somewhat pretty even. It's always good to do the math and make sure. Go ahead.
Did it have to have the second down 6 over 1?
No, no. You don't have to. This was just to show you that when we have slope, we could make a million more points. We could keep going with it forever and ever. All right. Now, let's write our x-intercept in, which we found out was 2, 0. Okay, guys. That was our do now. Let's talk about, did you need to write it? Here, sorry guys, I'll put it back up. All right, we have 1, 2, 3, 4, 5, 6, 7, 8. Let me just draw it on my pic. Well, no, I guess that didn't work. Okay, 2, 4, 6, 8, 10, 12. Nope. I know, girl. 12, 0. Right, that was our, I'm wrong. Guys, I'm sorry. I'm trying to do too many things at once. I know, I'm always telling y'all to slow down. I need to slow down. 0, 12 is that point. And then the other point that we found, we went down 6, 2, 4, 6 over 1. This point was, let's see, our x value is 1, our y value is 6. And then we also found that x-intercept, and that was 2, 0. And then our line went through.
So why is
Here.
mine not on?
I have a question.
Yours looks correct.
Okay.
Yeah, it looks perfect. Yes, Bree.
Okay, so if it's easier for me,
Mm-hmm.
I can do the math first.
Yes.
I have to do all that weird stuff.
Yes. You absolutely can do the math if that's easier for you.
I mean, yeah.
Now, the only thing is, on our quiz that we have coming up, there will be one question where you have to identify the slope, the y-intercept, and the x-intercept, but that is only going to be one of the questions. The other questions are going to be, here's a line, graph it. So if you need to come up with 3 coordinates every time like we did before, you can do that. It's just whenever we get the hang of this method, it ends up being a lot faster, so we can save time.
I think maybe once I sit down and watch the
Right. I think so. I think missing yesterday probably puts you a little bit behind, but once you watch it, hopefully it'll make some more sense.
Slope is always the line.
Mm-hmm. Okay, guys, we are going to move on.
Okay.
We need to look at our topics for today. Today, what we are working on is converting from standard form to slope-intercept form. All right, let me get this where you can see it. And you don't have to write down the topics if you don't want. I'm just giving you kind of a full disclosure. This is what we're doing today. So we're going to convert a equation in standard form to slope-intercept form. Then we are going to learn how to graph equations that are just like y equals 5 or x equals 2. Something where all it is one value they give you. We'll show you how to graph those. And then our plan is to have a quiz over these units on Thursday. All we're going to be doing on the quiz is graphing equations, and then there's one question where you have to identify slope, x-intercept, and y-intercept. So nothing else is going to really be brought on here. It's just what we've been working on for the last week or so. So this will be a smaller quiz, guys. Okay. Does anybody still need this up? Again, you don't have to write it, but I'll give you time to if you need it. Pause it. All right. So first, we're going to talk about when we see an equation in standard form. That's whenever we see it one where there's a number, then an x, plus another number, then a y, equals another number. We're going to take that and convert it to slope-intercept form. Now, why might we want to have an equation in slope-intercept form? Why would we want to convert it? Does anyone have any ideas?
Easier.
Yeah, it's going to be so much easier to work with. In standard form, you have no idea what the slope is. You have no idea what the y-intercept is. You would have to solve for all of those. But once it's in slope-intercept form, we can look and know right away, here's the slope, here's the y-intercept. And you only need 2 points to draw a line. So if you can see those two, you don't have to do any math. You can just draw that line. So let's start with that first. And I am going to show you here. All right, so we are going to start with the standard form equation. So I'm going to write that out again. That is ax plus by equals c. Now, we want to get this to turn into y equals mx plus b. So in order to do that, let's start by looking at an example. I'm going to write out, let's do 4x plus 5y equals 15. So here we have our x and our y on one side, and then we have another number on the other side of the equal sign. For slope-intercept form, we want to have just y by itself, and then our x and our other number. So in order to do that, we need to rearrange this equation by moving some of these numbers and variables around. So I'm going to walk you through the process first, and then I'm going to have you guys kind of join in and help me. So first of all, I see that I have an x and a y on this side. I want there to just be a y. What could I do to get rid of this x? I hear two things. I hear move it to the middle. I hear divide by 4. Any other ideas? Subtract. So if I divided by 4, I would still have an x there. I would just get rid of the 4. We want to get rid of the whole 4x. So we're going to do minus 4x. And we're going to bring that over here to the other side. And my x's are gone on this side. All I have now is 5y equals, and if I look over at my slope-intercept form, I want my x to come first and then plus b. So when I do minus 4x, I actually probably want to write that first so that my x comes first, and then we still have a 15. So we can just bring that down as plus 15. Okay, Anybody lost as to how we've gotten here so far?
Well, I'm just confused on how the plus sign, if we got rid of the 4.
Uh-huh.
To me, as a plus 5y equals 15.
Yes. So whenever we took this 4x away from this side,
Yeah.
we had to do the same thing on the other side, and I probably should have just wrote it here. I don't know why I wrote it off to the side. We're doing minus 4x on this side. So if I were to do 15 minus 4x, we can remember our addition and subtraction rules. When you subtract, you're really just adding a negative. We could also know that if we started with negative 4x and I have a positive 15, to show that those two are together, we just put a plus sign in the middle of them.
Okay.
Does that make sense?
Yeah.
Okay. All right. So, we're not done yet. In slope-intercept form, there's no number in front of y, ever. It needs to just be y. So now, what can I do to get y by itself? You okay?
We're gonna divide 5 by
Yes. Now we're going to divide. So, I'm going to divide this by 5. And we have to divide everything on this side by 5 as well. So we're going to be dividing negative 4 by 5 and 15 by 5. Whatever you do to one side has to do everything on the other. So what happens to my 5s?
Cancel that.
Those cancel. So we've got y equals. We're going to keep this as a fraction because slope is easier to read as a fraction anyway. So we're going to keep negative 4/5 x, drop down our plus, and what's 15 divided by 5? 3. Good. So we're going to put 3 here, and now if we look, we do have y equals, our m is negative 4/5, x plus 3, which is our b. So we just took an equation in standard form and we converted it over to slope-intercept. So,
So the negative 4 is the rise, the 5 is the rise.
yes, exactly. So let's use this equation and practice identifying those parts. We're going to forget about x-intercept for a minute today, guys. Let's just focus on the y-intercept and the slope because I don't want us to worry about doing the math there just yet today. Let's do our slope for this equation and our y-intercept. So first of all, what's our slope?
Negative 4 over 5.
Yeah, it's going to be negative 4 over 5. Now, what is our y-intercept? 3. And if we wanted to write that as a coordinate, remember we just found the y-intercept.
So it's a 0, right?
Yes, so our number goes in the y spot. Remember it's x then y, so we would put a 0 in for x and our y is 3. So we just found that, you guys. That's awesome. Now let's try graphing it. I'll give everybody a minute to get all that written down. So I'm going to get my graph ready. Okay, so we have a coordinate and we have our slope. What should we do first to graph this equation? Yeah, we're going to graph our y-intercept. We're going to go ahead and graph that 0, 3. So where am I going to put that? Yep, in the middle. We're not going to go over on any direction in the x because our x is 0. And then our y is 3. So we'll go 1, 2, 3. Right here. 0, 3. Okay, we now have our y-intercept graphed. What can we do to make another point?
Down 4 over 5.
Yes, we're going to look at our slope, which is negative 4 over 5, and we're going to remember that slope tells us rise over run. So our rise is negative 4, so we're going to start from that point we just plotted and go down 4. 1, 2, 3, 4.
Over 5.
Over 5. So our run is 5. We'll count over 1, 2, 3, 4, 5.
I guess that makes a little more sense now.
Good, good. And we'll keep doing
I
more.
just think it's because I'm more comfortable with it, you know?
Right, right. The more we do it, the easier it'll feel.
Like we were looking here yesterday.
Exactly.
So we put number negative 4, 5 in the parentheses.
Mm. Okay, I want to point out a question that Candy just asked. It was a good question. She asked, so for our point down here, are we going to write negative 4 and then 5? Are we going to do that?
Oh, no, we got it.
Oh, yeah, we got to count where our coordinate is. We got to check the location. So, remember that whenever we write a coordinate, it's the x value, then the y value. So, let's start by counting our x's. Ready? 1, 2, 3, 4, 5. So, our x is 5. And our y is how far up or down we go. So, we're going to start from here and we go down 1. So it's going to be 5, negative 1. Okay, we have 2 coordinates. That's all we need to graph a line. Let's go ahead and connect the dots. And then draw arrows on the end to show that they go on forever. And there's your line we just graphed.
So the y-intercept is negative 1.
The y-intercept that we just found, so the y is wherever the line touches that y-axis. So this is our y-axis.
Okay, yeah.
And we see that the line touches it right here at 0, 3.
Okay.
So our y-intercept is 0, 3. All right.
And the x-intercept would be negative 1.
Let's look.
5.
The x-intercept is wherever the line touches the x-axis. So in this case, it's somewhere about here, right there. So our x-intercept is going to be around 1, 2, 3, 3.5-ish. I'm not going to have you identify that for now,
Okay.
but if we did solve it, we know that we'd get a number close to 3.5.
Okay.
Okay, let's do another one. Let's do, and I'm going to give you guys a heads up real quick. This one that we're about to do, I would really write it in your notes. I would really, really make sure you don't lose it, because it may or may not be one that you'll see again one day. Just saying. Okay. Let me get a new piece of paper for you. Come on now. My Lord. Okay. So, here is another example. We have x minus y equals 2. Okay, so remember, slope-intercept form is y equals mx plus b. So we want to start by rearranging this equation so that it becomes in slope-intercept form. We want to turn it into that. We want to convert it.
So we're going to subtract x.
Yes, we're going to subtract x.
Which is 1.
Yeah, so the other thing we can remember is if there's no number next to our variables, we know that there is an invisible 1. So if that helps, just write your invisible 1 in there so you can see them. So what Bree just said is we're going to start by subtracting that 1x from that side so that it is on the other side. So our x's are gone over here. We'll bring down that negative 1y equals, and remember in slope-intercept, we want our x to come first. So we would write negative 1x plus or minus 2? Plus 2, because it's just a positive 2, guys. We would only put a minus if it was a negative 2. So plus 2. All right. Now we have negative 1y equals negative 1x plus 2. Now we're going to divide negative 1 from y so that we can get y by itself. Sorry, I heard you say you're confused. What are you confused about? Tell me about it. If you're confused, I bet somebody else is too.
I am. Go ahead, Sean.
Sorry, I get the ones and everything.
Yes.
So when there is never a number with the letters, we automatically go with 1.
Yes. Yes. So if I were to see this is an X. How many X's are on this sticky note? 1. So I don't have to write the number 1 for you to know that there's 1 here. We know by looking at it that there's 1. We always assume that there is only one of the variable unless we are told otherwise, like having a 2 or a 3 or a 4. Yes, Bree.
So for this equation though, because there's a negative y, we clearly have to get that not negative
Yes.
anymore. So if it was positive though, we wouldn't have to do anything else, right?
Nope, that is correct. That is correct. Because, and I'll show you maybe that scenario here in a minute. I don't want to confuse anybody yet, so let's continue here. All right, so we still need to get rid of this negative 1. So we're going to divide by negative 1. And remember, when we are dividing on the other side of the equation, we need to do it to everything. Negative 1, negative 1. Okay. Now, what happens? Yeah, my negative 1's cancel, so I just have y equals. What happens when I take negative 1 divided by negative 1? It becomes positive. Those negatives cancel. So I can just write 1x. And then what about when I take 2 divided by negative 1? Yes, it becomes negative 2. So we write minus 2. Are we done? Guys, we're done. We now have y equals 1x minus 2. Okay, now that we have found our slope-intercept form, let's go ahead and identify the parts. And again, this one's important. Yeah, let me write these. And just for fun, we'll find the x-intercept on this one just because that might be something you need later. Okay, what's our slope? 1, or you could say 1 over 1. Absolutely, either one is correct. 1. I'm going to write or 1 over 1 if you want to go ahead and have it in that rise over run form. Perfect. Now, what about our y-intercept? Yeah, the number is going to be negative 2. So when I write a coordinate, where does my negative 2 go? Yeah, it goes on the right side in my y spot. So the other number is going to be 0. And in case anyone is confused, I'll label these x and y. Okay, now our x-intercept, how are we going to find that? Okay, I hear some dividing negative 2 by 1. Let's start by making the empty coordinate so we know what we're solving for. So for the y-intercept, we set x to 0 because we're solving for y. For the x-intercept, we're solving for which one? For x. So we're going to set y to 0. Okay. Now we can take this coordinate and kind of plug it into our equation here. I've got y is 0, so I'm going to put 0 equals, and then I'm just going to drop everything down, x minus 2. And we're going to solve for x. What do I do here?
You have to move
Say that again?
You have to move the 2 so that we add 2.
Yes, exactly. We would add 2 to both sides. The 2's cancel. And we found x. X is 2. So our x-intercept would be 2, 0.
So, and then we would have to graph this.
For this one in particular, let me check. I don't think that I'm making you graph this one, but I'll double check before we move on. Yeah, let's go ahead and graph it.
Dang it.
It's all right, guys. We already have 2 points, so it shouldn't take too long to graph. Let's do our x and y axis. Okay, what could we do first?
You
Your y-intercept.
Yes, we have our y-intercept. That's going to be our starting point. So we're going to plot the coordinate 0, -2. So in my x direction, I go over 0. In my y, yes, thank you, I go down 2. So 1, 2, right here. And I'm going to label that 0, -2. And notice that the y-intercept is just wherever the line is touching the y-axis. So your x is always going to be 0 for a y-intercept because it has to touch the y-axis. Okay, what should we do next? Yeah, we could do the slope to find another point. So what's our slope? Yeah, our slope is 1. Our rise over run is just up 1 over 1, up 1 over 1. So we're going to start from the point we found, the y-intercept, and we're going to rise up 1, run over 1. And there is a point that we found. So you could just connect your line from there and be done. But we also found the x-intercept, so let's go ahead and plot that too. So 1, 2, and up 0. I'm going to label that one 2, 0. Okay, all you got to do is connect the dots now. Get that straight, or straight enough. There we go. That's our line, guys. Okay, so we are going to go ahead and pause here for now because it is about to be lunchtime. Okay, all right, welcome back from lunch, guys. We are gonna do one more example of graphing an equation without having to find specific coordinates. Let's go ahead and do, let's try 6x plus 2y equals 24. Okay, so we're starting with an equation that has x, y on the same side equals 24. What do we need to do to our equation first to get it to our nice looking slope-intercept form? Yeah, we're going to try to get that y by itself. So what would our first step be to getting closer to that? Yeah, let's get the x on the other side. Let's subtract 6x from both sides. All right, these are going to cancel. Then we're going to bring everything down. I've got 2y equals, and remember we want that x term to come first. So we're going to write negative 6x, and we've got a positive 24 here. So we'll write plus 24. Okay, where do we go from here? Remember what our goal is here is to get our equation to be in the slope-intercept form where we have a y by itself equals our slope x plus our y-intercept here, mx plus b. We still have a 2 connected to our y. So how do we get rid of this 2 and get y by itself?
Subtract.
Ooh, 2y is the same thing as 2 times y. So we got to divide. Thank you. We're going to divide by 2. Divide everything by 2. All right. What happens now? Yep, my 2's cancel, so I'm left with just y. Negative 6x divided by 2. What's that? We could leave it, but it's not simplified. We could simplify this further. Negative 3x. And if you wanted it to be a fraction, so it's easier to see the slope for rise over run, you could just do negative 3 over 1. And then 24 divided by 2. Just positive 12. That's okay. We have a positive number divided by another positive.
I will get that.
You'll get it. All right, so we're going to write plus 12. All right, we have our y equals something x plus something. Y equals negative 3x plus 12. Now, what we're going to do is identify our y-intercept and our slope. So I'm going to put y-intercept and slope.
So just to make sure I'm understanding correctly,
Mm-hmm.
so your x, your mx, we do not leave it unless it can be, or you don't divide that out if it can be simplified, right?
Yes. So if we got, well, like what we did here, 6 over 2, we can go ahead and turn that into 3 over 1. The reason that we didn't simplify this one, negative 4 over 5, is because there's no way to simplify this further.
Okay.
Unless you wanted to put it at 0.8.
True. Could be a decimal.
Okay, thank you.
Absolutely. Okay, so let's look at our equation. What is our y-intercept? 12. Good. So I'm going to write 12. And then we also need to write the coordinate. So, yes, 0, 12. Why is it 0, 12 and not 12, 0?
Because this is on the rise already zero.
Yes. So anytime we're looking at a coordinate, we know that the first term is a 0, or sorry, an x. And the second part is our y. And our y-intercept is telling us where the line touches the y-axis. So we need to have a y value here. Our x is going to be 0. Perfect. All right, now let's identify our slope. What is that going to be?
Is it okay if you speak for them?
Yeah, that's fine. What's our slope?
3 over 1.
We've got,
Negative 3 over 1.
yeah, pay attention to your signs. That's okay. We have a negative 3 for our slope. And if we wanted to write it in that rise over run form, we could also write negative 3 over 1. All right. Now, let's graph it. Let's graph it.
We have someone at the door.
Oh, we do? Who is it? Hello, Toby. What's up?
Just watching.
Sounds good. Okay, so we have our y-intercept and we have our slope. First, before we start plotting any points, make sure that we have our x-axis and our y-axis labeled. So remember, our y goes up and down, and our x goes left to right. So what's the first thing I'm going to do now?
Intercept.
Yes, I need to graph my y-intercept. So my y-intercept is at 0, 12. So on my x-axis, I'm going to go over 0. And on my y, I need to go up 12. So I'm going to count by 2s to make sure I have enough room. 2, 4, 6, 8, 10, 12. Right there. And then we want to label that 0, 12. All right. I'll let everybody get that plotted. And I'm going to just draw some more little tick marks here. Okay, once we have our y-intercept plotted on our graph, yeah, we're going to do slope next. So our slope is -3. We know slope is what? Rise over run. So what are we going to do here?
Go down 3.
Yes, go down 3 from where?
Point we just made.
Yeah, from the point we just made. I've seen some people start over right here at our, what would normally be the start point. But remember, our slope is the steepness of the line. And we know that this point is part of the line. So we want to stay on the line when we're doing slope. So we'll start from this point, and our rise is -3. So we'll go 1, 2, 3 down. And our run is 1. So we're going to go over 1 right here. Here's that second point we made. Okay, and then all we need to do is label what this coordinate is. So how am I going to figure out what the x and the y are for this coordinate? What are we going to do?
Going down 3.
Okay, I heard 3, 1. Let's look. So whenever we have a coordinate, remember, it's just a point that is giving us a location. It's telling us where it is on the graph. So I want to count how many units I move in the x direction as my x, and then how many units I move in the y direction for my y. So, okay, I heard 6, 1. Remember, we have x first and then y. So let's count our x together first.
Oh, 1, 6.
Yeah, 1, 6. So we're going to start from 0 and we count over 1 space because this is at 1 here. I know it's a little far away, hard to see, but it is at 1. And then we're just going to count and see how high up it is on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, so 9, not 6. Where'd you get 6 from?
Because I only have 6 marks on my thing.
Oh, gotcha. So, okay, yeah, we got to be really careful whenever we're counting. Make sure we're using the right scale. So I had to break my my units in half because I didn't draw a big enough graph. And you might have to do that too. Just make sure you know exactly what it is you're counting. If it helps to label it, maybe put like a 2, 4, 6, if that helps, you know, that way you know what you're counting. Okay, what's our last step here? Draw a line. We're just connecting the dots, guys. So I am going to get out my ruler. Let me see.
These are 2, just see 2, 4, 6, 8, 10, 12.
Okay, so remember our slope was -3/1. So you would start from here and go down 3. So you'd go 1, 2, 3, and then we go over 1. So your point would be right there. Does that make sense?
Yeah.
Okay, good. All right, let me draw that line so everybody can see.
Because I forgot that my line were 2.
Yeah. I get ya. Okay, and make sure you don't forget the arrows on the ends, guys. That line is not a segment. It does go on forever and ever. So that's what those arrows are going to tell us. Okay. Any questions about this example? All right. Okay. In that case, let's move on to the next topic today. That is going to be graphing equations that look like this. Y equals a number and X equals a number. So these are a little different. We're used to seeing the slope-intercept form where there's Y equals some X plus B, or standard form where we have a number with X, a number in Y, and then a number. Okay, this one is either going to have just a Y or just an X. We're going to start with Y's first. Okay, so what I am going to do is I am going to kind of write out a little explanation for this. Whenever you have an equation that is just Y equals a number, in this case Y equals 1, this just means that no matter what your X value is, no matter what your X value is, your Y value is whatever number it says. So for number 1, it would be 1. So let's make a couple of points here. Let's do 2 because that's all it takes to make a line. So I'm going to label my X and my Y just to remind myself where they sit in the coordinates. I meant to make that X red. But you know what? Now it'll be all right. Okay, so just like we said over here, no matter what you choose for your X, your Y is always going to be 1 because our equation tells us Y equals 1. So what we're going to do here is we're just going to put 1 for both Y's. We know our Y is always 1. And we can pick any random value for X. Who has an X idea? 2 and 3. Let's do it. 2 and 3. Okay, so there's 2 points. Let's go ahead and draw a little mini graph. I'm going to zoom in for you. And this one doesn't have to be super big. Okay, here's my X, here's my Y. There's 1 for Y, and then my X goes 1, 2, 3. All right, let's go ahead and graph these 2 coordinates that we discovered. Our first one is X is 2, Y is 1. So we're going to start at 0, and we want to go in the X direction 2. So 1, 2. And then we're going to go in the Y direction 1 right here. So there is our first point. Now let's do our second one. We're going to go in the X direction 3. 1, 2, 3. And we're going to go up 1. 1. Okay. Now all we got to do is connect the dots. And what would you know? It's just a flat line. The reason that there's not an x in this equation is because whenever we have a line like this, it has a slope of 0. There's no steepness to this line. If there's a 0 for x, x just disappears. So anytime you see y equals a number, it's just going to be a line going left to right at whatever point it says that y is. So in this case, it's going to be on number 1 in the y direction, going left and right forever. Okay, let's look at number 2. Number 2 is going to be super similar. So same thing, whatever your x value is, your y value is what? 5. It tells us right there, our y value is going to be 5 for this equation. So let's come up with 2 points, 2 coordinates. All right. What do we want to put for our x's? Doesn't matter. What'd you say?
1 and 2.
I heard 3, 4, 1 and 2. How about I do 1 and 4? Compromise. Okay. And then what's our y going to be for both? 5. It tells us right there y is always 5. So we're going to put 5 in there. And now let's do a little mini graph again. Just make sure that you have enough room to go up 5. That might mean you need to do double points again, like 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. All right, let's graph our first coordinate. Our first coordinate is 1 for x, 5 for y. Perfect. Go over 1, up 5. 2, 4, 5. Right here. And then let's do our second one. Perfect. Over 4, up 5 again. What do we need to do now? Draw a line. You're just connecting the dots, guys. That is it. So remember, your y tells you the height. So anytime you see y equals, you can know that you're just going to get a straight line with 0 slope, and that line is going to cross the y-axis wherever it tells us in the equation. So no matter what x is, y is always 5. Any questions about that one? Okay, number 3 and 4, I'm going to have you guys try on your own. And I'm going to pause our recording. So if you are watching this at home, pause it and try it yourself. Okay, let's look over number 3 and 4. I added 5 and 6 for my friends in class to try. Just for reference, that's why they're there. Alright, let's look at y equals -5. What are we going to do, guys? Say that a little louder. I'm sorry, I must be deaf.
Make up 2 more coordinates first.
Yeah. We're making up coordinates. We just need 2.
-1. Or y is -5 on both of them.
Yes. Y equals -5 means that every coordinate you plot, no matter what you choose for x, y is always -5. So give me 2 random numbers. 1, 2. Okay. We're going to go ahead and draw our graph, and it doesn't matter what you used as your coordinates, your line's going to look the same. So we've got -1, -2, -3, -4, -5, and then we chose 1, 2. Yes, Chance.
So
y equals a number, it's a constant, right? And x is a constant as well?
What do you mean by constant?
Like it never changes, like this is just an example of like x is always 2 or y is always -5.
Yeah, in that way, absolutely, that would be a constant. So your constants are those numbers that don't change.
So it will always be either a 0 or an end-of-line slope, right?
Yes.
I thought it was wrong.
Nope, you're doing it right. Awesome. Okay, let's go ahead and plot the points for y equals -5. We did 1, -5. We did 2, -5. And guys, your line should look just about like mine. You are going to get a line that goes horizontally forever in both directions. Just like that. At y equals -5, it'll go on forever and ever in both directions. Any questions about 3? Okay, let's try number 4. I'm going to just start by drawing this. And, oops, you can't see that. Let's go ahead, count out 10. I don't know if I made 10. That's all right. Okay, at y equals 10, how about this time without plotting points? What am I going to do? What could I do without plotting any points?
Just mark 10 on the y.
Yeah, I'm just going to go up to 10, and I'm going to draw a line right there, straight across. Because I know that no matter what I choose for x, whether it be over here, it's always going to be at y equals 10. So I could even just draw some little dots up there. That's always going to be at that point. Always. Okay, how does that make sense to everybody? Everybody feel okay about that?
Yeah, absolutely.
Good. We needed a win today. We needed a win. All right, can we look at the x's now? Awesome. All right. So just like here with your y's, for y equals 1, no matter what your x value is, your y value is 1. For y equals 5, the y value is always 5. What if we are given x equals 2? What points could we come up with? Okay, so 1 and 4. Where am I going to write that though?
You're gonna be to the left. Your x is gonna be 2.
Yeah, guys, I'm hearing a lot of correct answers. In this case, yeah, we have x equals 2. So in the x position, we're always going to have a 2. Always.
I'm not ready.
And then, I'll wait for you, Star.
No, I'm joking.
Okay. So, when it says x equals 2, it means what it says. X is always 2. And then our y can be anything. So, I don't know, let's just do 1 and 2. Now we're going to draw our graph. And it's very important that we remember which one is our x-axis and which one is our y. So I know we didn't label it on all the others, but let's go ahead and do that again. Get back in the habit. There's our y. There's our x. Let's plot these points. We have, the first point is 2, 1. So we're going to go over 2, up 1. Perfect. Okay, now our next point is 2, 2. So we're going to go over 2 and up 2. So as you can see, guys, our line is going to be not horizontal this time. Instead, we're going to end up with a vertical line going up and down. Because no matter what my height is, my y value, doesn't matter if it's positive 2 million or negative whatever. My x is always 2. So it's going to be a straight up and down line that goes on forever.
You got it.
You got it. Good. Awesome. Any questions about number 5?
No, just pay attention to what you write down.
Good deal. Okay, let's check out number 6 now. I've got x equals -3. So what does that tell us? When we're writing our coordinates, we know x is -3. So what is our for sure thing that we can write? Yeah, our x spot always going to be -3. So I'm going to go ahead and fill that in. Now our y, we can pick anything. Throw me some numbers. I heard -1, I heard -4. I'm going to do them both. Okay, let's draw a graph. And I want to make sure I have enough negative numbers. So that should be good. Okay, so let's go ahead and plot our first point. We have -3, -1. So, again, I'm going to label these. How many am I going in the x direction? -3. Since it's negative, we go this way to the left. 1, 2, 3. And then our y is -1. So we just went over -3. Now, because it's negative, do we go up or down? Down. So here's our first point. All right. Now let's do our second point. We've got -3, -4. So same thing. Our x direction, it stays the same. We're going over to -3. And then our y is -4. So we go down 4. Good job. 1, 2, 3, 4. There is our second point. All right. We've got 2 dots. We can make a line. So, as you can see here, same as number 5, you're going to get a vertical line going up and down, and it's always going to be at x equals -3. Always. So whenever we have a value or a line like this, you don't need to know this, but in case you're curious, we call this an undefined slope. We call it an undefined slope. That's because we don't have any y here to solve for. We just have an x, okay? If we have y equals, we've got a slope of 0. When we've got x equals, it's undefined. Again, you don't need to know that, just a little FYI. Okay, let's check on the time. We've still got a little bit. Here is what we're gonna do. Does anybody still need to write any of this, by the way? I don't want to take it away too quick. Okay. We are going to go ahead and... I forgot I put all these on the back of this page. Do we feel good about these, or do we want more practice? Okay, I'll leave them up here for a minute while I talk to you in case anyone wants to write them down and practice on their own. But I think you guys got this. We're going to go ahead and put the exit ticket up for y'all.
No.
I know. While I get that ready, I'm happy to go over another example of converting from standard form to slope intercept. So I'm going to get that out real quick, and then we're going to go over that together one more time for anybody that wants a little refresher. Okay, well, I guess let me look on here real quick. Okay.